Yeah, good morning. Today I'm going to talk about pumps and electronic systems that power and provide water for EPIC cells in general, from as small as a planter to a large sports field. Pumps come in many varieties. There's probably hundreds on the market. Now, for example, on a small end, this little DC pump delivers 200 liters per hour. You just plug it into your power source grid, and it can provide that water to your planters or garden beds or even a backyard. The flow is large enough to do that job. Another option for pumps are DC powered pumps. This is a submersible pump, delivers 1,000 liters per hour. So this is placed in the bottom of your reservoir or pond or whatever, and then feeds the water to your EPIC garden. Now, these systems are kind of simplified. If it's a recirculating system, you just plug it manually on a certain day, let the pump run, because the returned water goes back to the reservoir and no water is wasted. We're simply circling the water through our interconnected systems of EPIC. And these pumps are, again, another type of pump. This is a surface mount pump. This is popular in the RV industries with remote camping and boats and yachts and whatever. This has a suction hose. So the suction hose sucks from the reservoir. It can suck up to 6 feet or 2 meters of water level vertically without a prime. If it's primed, it'll suck a little deeper. Now, one thing about these pumps, these are pressure regulated pumps. So they provide pressure on the downhill side of the pump. So the suction side is the vacuum side, and the pressure side, before it goes to your service line, is always under pressure. This pump, for example, is 45 PSI. Now, because of that, the line to your first device or control mechanism should be pressure rated and as short as possible, because it maintains a constant pressure. Now, in this case, we have standard irrigation valves that control the on-off cycle to your supply line. Now, the problem we have with conventional designs, this conventional irrigation valves work on a 24-volt system. The pump itself works on a 12-volt system. So now we have the quandary. We have 12 volts going to 24 volts AC. How do we control that situation? And that's where the EPIC control box comes in. So the EPIC control box is a small, watertight, rubber gasketed box. You can clip in and shut it off. You can lock it, and it's permanent installation. On the outside of the box, there's 6 terminals. The first 2 terminals right here, we have the 12-volt input from your solar panel or the battery that the solar panel charges. So we have to kind of match the solar panel. Is the wattage enough to power the pump that you've selected? The larger the pump, the larger the solar panels needed. A solar panel a third of the size can probably operate this pump because it doesn't have wattage. So engineering wise, what determines what is my water need, how large is the water area, what power do I have? So the situation I have set up here, we're going to have situations where we don't have power because we're in a rural or remote area. There's no houses, no homes, and we want to operate systems to irrigate trees, for example, in the forest, but no one is around. How is that going to work? Well, it starts out, we can get 12-volt power by a solar panel. The solar panel is going to be activated only when the sun shines. So if the solar panel is connected to the pump directly, that system will only work when the sun is shining. which is probably adequate in small systems. But we're only watering twice a week maybe, or once a week. So that one strategy is the solar panel can charge a battery, because the solar panel, instead of the sun going wasted when the pump isn't running, it actually charges the battery. When the battery is charged, we can pick up the power that we need, the 12-volt system, to the box right from the battery. And this is what I've done here. We have a 12-volt system, the positive and negative connected to the terminal. The next terminal is a 12 DC system connected to my operating pump. And then the third terminal is one leg goes to the float switch, which is inside the EPIC unit. And the other side goes to the solenoid valve on your irrigation valve. Okay, so when we look on the inside, what is pre-wired and really doesn't need maintenance is the unit. We have a timer which has 168 settings of different times of on-off switch. It works on a 24-hour cycle, so 1 o'clock is actually 13 hours. Now this was preset some time ago, actually a month ago, to be on for 6 hours on Tuesdays. Otherwise, the whole circuit is off if the timer, if it's Wednesday, Thursday, Friday, whatever. But on Tuesdays, the timer will kick on, the red light will come on and supply power. So that power from the 12-volt input is going to be transferred first to an inverter. So the inverter will change the 12 volts to AC power. And the 110 AC power then goes to a transformer, which transforms the 110 AC to a low voltage 24 volts AC, which is needed to operate the unit. And being 24 volts AC, the switch inside the EPIC system, which is connected to the irrigation valve, doesn't get a lot of current, so we can use very small float switches that operate without having a lot of power through them. So when the float switch is down, the circuit is complete. When the water rises in the unit, the system shuts off, and I'll demonstrate that shortly. So the power supply, again, from the pump goes to a typical inlet valve. The inlet valve from the pump goes in here, and this would be the ground level. This is buried underground, and we have a valve. Inside the valve, we control the flow rate. If it's connected to a single row of EPIC cells, the flow rate should be about 4 liters per minute or thereabouts. Now the pump we have designed or perfected may serve a lot of these units, 4 or 5 or more. So each unit is the first time adjusted to a flow rate of 4 liters per minute. And then that water goes down the unit and goes inside your first or starting cell. And then it cascades by gravity, no pressure flow, to the final float switch arrangement, and then that float switch arrangement goes to discharge. So this is not a recirculating system, this is a straight through system, but we don't want the pump to run even when water's coming out, because we'd be wasting water. So we want the shut off to occur even if the pump is running and the unit is on, so no water is necessarily introduced. So let's work on a system. So the unit, we first have to clear the settings so we can operate the pump. So right now I'm going to a manual mode. So the manual mode it's running, and the reason it's running because the float switch is down. The circuit is completed, so the water's coming into the inlet, cascading through the units, and this might be running for hours. At a certain time cycle, the water is going to reach the last unit and start to rise in my float switch containment. And as it rises, the float switch goes up and the water stops. If the float switch is down again, the water runs. If the float switch starts to float up, the water stops. Okay, so I manually shut off the water supply. Now I don't have power to the inverter or the AC volt, so really nothing happens, even though I have 12 volt power to the unit. All right, thank you. I hope that's clear, but call us anytime with questions. Bye.